Hello and welcome to this wonderful panel discussion on data centricity and AI. I know these terms are very nebulous concepts, and we might be stumbling through the dark to make sense of everything. You hear a lot of things through marketing channels, through sales channels, through social media, and it's kind of hard to tell what is the truth and what is based on experience or what is based on the hype. So today we're going to dispel some of those obfuscated ideas with this wonderful panel. I'll go in alphabetical order, starting with Andrea Gioia, uh, partner at Quantica and Blind Data. Thank you for joining us. Dr. Giuseppe Futia, senior graph data scientist. He is a published author. Can you specify your book, Graph Data Science? No,
No, actually, the book name is Knowledge Graphs Applied, but
Knowledge Graph Applied. Yes,
it's a
and
tentative title, right? Let's see if it will evolve.
Dr. Hala Nelson, thank you for joining us as well. You're a professor of mathematics at James Madison University, and you're also author on Essential Math for AI. But you are writing a Substack now.
Yes, I'm writing a Substack on foundations of AI and data because math gives you the models for AI and the applications, but you also need like the infrastructure and the culture and everything.
So, Andrea, you're in the midst of writing your book as well. So, this is a panel of authors. At the end of this, we're going to share the links to the respective titles, and you guys should put that on your reading list. So, with that, on with the show, and I'll start just by asking. We talk about data, we talk about data infrastructure, we talk about solving business use cases. Um, but what does that all mean? At some point, you need to model actual business operations because that's what derives value for an organization. How do we get revenue in? How do we fulfill this promise that we have, and how do we ensure we keep that revenue and deploy it effectively and efficiently? Um, so, what is modeling, and how much is enough for it to be useful?
Yeah, maybe I can start if you want. Well,
Go,
I
go.
would say that this you touched a really interesting and really important point, Joaquin, right? Because with the terms data modeling, and this is my personal definition, it's like a framework, right, that you define to resolve a specific problem or develop a specific features in your products. So the key idea on my side is to start very little, right? Start from the most granular level to develop uh, the enough data model that is useful to address your problem and to develop your features. And when your needs change, right? When you need to develop more features or you need to address a more complex problem, then you can start to extend your data model in order to create this sort of continuous connection, right, between the model that you use to resolve your problem and the features that you want to develop, right? Because I see that in many cases, most of the bad situation come when you start to define a really big and huge and complex model to resolve many and many problems related to a specific domain. And then at the end of the process, after months, you understand and you got that what you have defined, it's not useful for your specific purposes, right? So I think that having this bottom-up approach could be, in most of the cases, the best practice, right, in order to define your data model.
I agree with Giuseppe also because A model is a simplified representation of something that you design to solve a specific problem. So creating a model without a problem is very strange, and in a lot of situations is a waste of time, because when then the problems start to come in, you find out that the model that you have created is not a good fit for the problem that you have to solve. So I totally agree with Giuseppe that it's important to start with a bottom-up approach. So first of all, find the problem that are meaningful for your organization to be solved, and then from the problem, design the optimal model of the entity and the object that are correlated with the problem, and then use the model and verify your model and how it is good to solve the specific problem, and then problem by problem in a iterative way. Of course, you can create new models or extend the already existing model. It's also important, and then we will return on that when we are going to talk about probably knowledge graph, the fact that because the model is related to the problem, is designed to specifically to solve a problem, the same entity, the same object can also have a different, can be modeled in a different way, in a different context, because you want to resolve different problems. So this is absolutely fine.
Yeah, for me, I agree. And I would also add that before people start addressing anything, is step back and try to talk to as many stakeholders as they can on different levels of the organization, if they can, because all of these levels can see the same problem as they understand the problem in different ways. And if you're the person who's tasked to build that solution, you definitely need to understand it with different levels, so there is no misunderstandings. There's this ambiguity. I don't know how to say it.
Ambiguity.
Yeah, and on how so to resolve differences before and misunderstandings, and to actually pinpoint the actual goals and pain points before you start modeling. And the other problem that I've encountered is that people they start building the model that they learned. So if they know how to build one solution, they're gonna make the problem fit that solution, as opposed to building a solution for the problem, which could mean that they have to ask more people or read more books or ask so to actually fit a problem into a model that they know, as opposed to build a model for the actual problem that addresses it, I've seen more in the wrong direction in that sense. So that's always what I try to caution people about, is understand the problem and understand how, and always get feedback as you build the solution, whether this solution still aligns with the mission, the goals, and of the stakeholders and the people at different levels. So that would be my take on this.
I appreciate that collectively the idea is to work within an organization, kind of reconcile fragmented perspectives into one unified view, and then make it a practical, functional, use case driven approach. You're not going to go and look at a tool in the marketplace and say, wow, that looks really cool. I'm going to start implementing that and I'm going to fit that into a problem. And, later I'll justify ROI. We'll talk about solving a business problem in the future. But that's not the way that things work. And that's why a lot of projects die on the grapevine. People prematurely optimize in a particular segment, and there's no extendability, there's no immediate use case. When it could easily be a 1 or 2 months of additional conversations, requirement collections, and just refining that idea. Like, what are we trying to solve and how? Um, so this brings me to the next point. You guys said we'll start with modeling a particular area. As new problems emerge, adjacent areas will come forth as well. So at some point, you're going to address the same concept through different lenses, right? Whether it's a customer through marketing or through sales or through fulfillment, or whether it's a disease from where it's conceived, where it's treated, and where the pharmaceutical companies manufacturing a drug for that, we're looking at the same concept through different lenses. So let's talk about entity disambiguation.
Yeah, you touch another really interesting point, Joaquin. I think that named entity disambiguation, especially for domains like biomedicine and healthcare, in which you have a lot of knowledge that require to be systematized in some way. This is a really good example because in this domain, a lot of ontologies have been developed for different and specific verticals, right? Because, for instance, you can encounter ontologies on genes, representations, ontologies on phenotypic features, which connect, for instance, a disease and a specific, I don't know, part of the body that is affected by this disease. There are more general ontologies that describe the clinical process and so on. So in this specific scenario, with its peculiarities, the capacity of creating this connection between a span of text, right? So a specific word or a specific expressions to an existing entity in a well-defined knowledge base is fundamental, right? Especially when you have to manage a huge amount of content. I made this example in our previous session, but regarding, for instance, the Zika terms, right? This term can refer to the virus, to the specific disease caused by this virus, to the congenital syndrome, right, which is connected to this disease. And based on your purpose, you want to precisely identify which of these entities mentioned in the document. Because if you want to manage, for instance, a pandemic situation of the risk of a pandemics, you want to immediately access to all the reports that specifically mention potentially the Zika virus, right? But if you want to make some research activity and analyze, for instance, the fatal malformation that are related to this disease, then you want to access potentially to a completely different type of documents, right? Potentially clinical research and so on. So in the case of Zika, we have very similar concepts, right? But distinguishing between these concepts is vital, right? For the specific problem that you want to address.
Yes, I think that. Oh, please go. Yeah, first.
No, I
Yeah,
wanted
first.
to ask him I wanted to ask him how do you disambiguate? How do you do that in that case? How do you fix it?
Yeah, I mean, there are a lot of techniques, right, to perform this task. Some techniques include, for instance, the co-occurring entities in the portion of text, right? So, for instance, if we identify the Zika term in a sentence, right, and in this sentence we are able to identify other entities like fetal malformation of issue in intrauterine growth or something like that, then these entities can be combined as a sort of signal for the disambiguation. So in that case, you see the Zika term, but you know that you are talking about the congenital syndrome because of these other signals around the term. I mean, this is a technique that can be adopted, but obviously you can also apply other approaches. But this is the basic what you can do, right?
Yeah, I think that if we take the example of Zika and we bring it into an organization, also into an organization, we have concepts that are very similar but have different meaning and usage in the different subdomain. No? So, for example, instead of Zika, we can take the concept of customer, and the concept of customer maybe is common to all the subdomain within an organization, but each subdomain use their own specific language and give to the customer concept maybe a slightly different meaning. So it is also important when you are trying to implement and support business cases that cross domains, that need to collect data that come from different domain to reconcile the meaning of customer, of the data related to customer that is provided by the marketing domain, for the marketing subdomain, for example, with the data of the customer provided by the sales subdomain. So you have to put a mechanism in place to reconcile this data. And of course, it's important to understand that it's not possible to centrally define the one way to model the customer that is good for all the domain, because the different subdomain try to solve different problems. So what you can do is try to find out some common agreement of a general concept of the customer that can then be specialized by all the subdomain. But because all the subdomain, the ontology of the subdomain point to the enterprise ontology, so the common concept of customer at the enterprise level, you can translate, you can do this normalization on the fly and understand what are the differences between the customer used by the sales, the customer used by the marketing, what are the differences, and what are the common parts. So you can combine these two data in a way.
Yeah, the way I see this, I'm going to give a very simple example from when I wrote my book on math. I noticed because of all the different ways, because everybody who comes to AI comes from starkly different backgrounds, I realized that people would understand the same words as incredibly different concepts. So I ended up writing a whole book of math with words and with the least symbols I could use just to make people not confused, just to keep everything, including the equations, in context. So equations would have words plus other words plus like labels are fully expressive. So that's one thing. But what I've seen, this is like a very simple example of this very confusing problem. And the other thing is, for example, at my university, because now they're doing a whole new re-engineering of the whole data of 22,000 students, 1,500 employees, 149 programs. It's a huge institution. What they're actually doing is they're manually defining these data terms, like literally manually talking to a lot of people and in different domains and trying to come up with definitions and recording them and putting them in the metadata. So what I was very surprised is that and I've also talked to people in other institutions, is a lot of this work is manual and this okay, this ambiguity.
Ambiguity.
I can't really. I have to write it somewhere. Yeah, it has to be done carefully and correctly in the beginning in the model of each of these subdomains. And part of it is like a real good documentation and again revisiting and the history of a term. And so I feel like this is what I mean. I can't imagine that in an institution as big as mine, a lot of this work is being done manually. So that's why I'm very interested in hearing this conversation.
So
Yeah. Sorry, Joaquin, please.
no, I was just going to reconcile those perspectives, and I think I wanted to add also, Andrea, you mentioned about the context might matter, based like on what Giuseppe is saying. The different circumstances have different contexts, have different words of the same kind but different meaning, and that reflects in papers. But it is also contingent on the data set that you have available,
Yeah.
right? So if you know a particular entity and you define that in your system, but now you're looking through a different lens and you don't have any recollection of that in your system, there's something that needs to be mapped and there's a new thing that needs to be captured. So do you did you want to add something to that, Giuseppe?
Yeah, I think that this is an interesting scenario, Joachim, because if I come back to the biomedical domain, in that case, you have this sort of authoritative. Yeah, I have also issue with words. Authoritative knowledge base, right? That you can use for linking your span of text to the specific entity. But there are other cases and other interesting scenarios in which create this connection between the span of text and this knowledge base. It's not possible, right? Because if you think, for instance, about a situation like law enforcement or financial transactions, these are also some scenarios in which you want to perform this reconciliation process, as mentioned by Andrea, right? Because, for instance, if we consider cases like the Panama Papers, here and there you have some names, person mentioned here and there, right? And your key goal was not to connect this person to an encyclopedic, I don't know, knowledge base like Wikipedia, but you would like to identify if this name is represent the same person of the other document, or the same name actually represent another person. And in that case, you do not have this a reference knowledge base, but you have to perform this reconciliation and disambiguation process as well. And I think that this typical problem characterize all the situation and all these scenarios in which you do not have this reference knowledge base. And so the specificity of the data set that you mentioned, Joachim, becomes crucial, right? Because all the signals that you have are should be located in the data that you are analyzing, because you cannot exploit other information coming from external sources. And in this case, maybe we can talk about more, we can define this problem of like entity resolution, right? So basically identify a unique entity that could be mentioned in different texts without having an authoritative data set as a reference. But it's still important, right? Because not all the cases, not all the problems could be solved by this linking process to an external source.
But consider that this is for me it's absolutely interesting because even in a lot of organization there is not a model that you can referentiate, so they are trying to leverage large language model or other technique to do entity identification where they already have in-house the knowledge and the domain and business expert to create this central model that then can be improve all the activity, all the problem that you want to solve down the line by themselves. They can create the model by themselves because their business representative already know how the domain works, what are the problem, how to model the concept of the problem. No, instead, if you try to identify automatically the identity or the model of a domain, of a business domain, starting from the data, you will, in some way it is possible, but the distance between the reality of the domain and what is inferred by the data is still quite big. There is a lot of error, a lot of hallucination in the between. So you absolutely need to leverage the knowledge that you already have and formalize it in a model in order to improve all the activity down the line.
I agree 100%. And even when you're training the language model to map to your business glossary, it's not like all companies now have all this labeled data that maps their documents immediately to the business glossary. So they need their domain experts, but they also need to know how to even specialize that model before they deploy it to their different domains. So it really is a lot of manual labor. In my opinion, that's what I've seen is a lot of manual labor, but so far in like real organizations.
If I could just abstract this to the most generic sense, I mean, we are born into this world with senses, and we learn and grow, and we go to school, and then we go to college and we get specialized training, and our worldviews shift according to the context that we're exposed. Our knowledge, our experience, our wisdom is a composite of all the experiences, things that we've seen, heard, and touched, felt, all those things. Um, that means that we have fragmented views of the world, and the way that we reconcile that in technical systems is only a reflection of what is done. But what is available commercially is applications, or maybe some standard ontology, some standard templates on how to view the world. But that doesn't mean it reflects reality in the context specific or use case specific domain that we're looking at. And I think Hala brings up a good point that, you know, even if we're looking at it, that there are, as Andrea said, upper ontologies or upper patterns that are sort of social contracts we can agree to, and then further go down to lower levels and map out the subdomain specific ontologies. There is still that reconciliation, integration, curation process. What does this mean for you, Andrea? What does this mean for you, Giuseppe? What does this mean for you, Hala? And then how do we agree to the center, the common theme? So with that, with me just going on a little tangent there, what is the importance of viewing all this stuff as a data product? You know, it's knowledge, but we need to encapsulate it so it's human and machine readable. How do we treat it as a data product?
Yes, for me, the information architecture is basically can be represented as a pyramid. On the base, you have the data and the management of data, and then on top of it, you put the metadata that describe this data in order to put the data in a context and provide the meaning and make the data usable. And then on top, you try to formalize your knowledge about the information that you have collected, how the information can correlate to other information or can be used to take some kind of decision or drive some kind of action. So the first thing that you have to manage properly is the foundation, of course. That is how you are going to manage the data, no? And we have seen that traditionally we manage the data throughout a monolithic solution in which new data assets are continuously added and correlated to all the other assets into the solution. And this make this kind of data management solution very, very complex, no? And the complexity increase over time, usually in a quadratic way, because you want to connect all the data asset to all the other data asset, no? And this make this application in the long run not sustainable, because when the complexity is too much, the maintenance cost skyrocket, and the capacity to be fast in respond to the demand start to dramatically slow down. No? So basically, we see in a lot of organizations that are different generations of data platform. No, every data platform try to solve the problem of the previous one, but actually is just a replatforming on a new technology that represents exactly the same problem, and then in the next iteration you are going to replace also the platform. So modern approach to data management just apply a very simple engineering principle to data management. Let's say if a system is complex, you cannot manage this complexity as a whole. You have to divide the complexity, segregate the complexity in modules that allow you to isolate the complexity and do modification in isolation without have the necessity to have in your mind all the system, but you can concentrate only on a single component, forgetting about the rest. No, so this make us give us the possibility to create data management solution as a composition of module that can manage better the complexity and can evolve in a sustainable way over time. So for me, this is the reason why data products are very important right now, to manage better the complexity and to apply something that is already known in all other engineering practices, the divide et impera, no?
I'm gonna go at this from like an end user perspective as opposed to an engineer's perspective. Like the way I look at a data product is data that in the form that I can find and use. So basically, that's in the end why would anyone need this data? Is when you need it, you want access for it fast, and you want it in the form that you can operate with fast. And then if you and access and create insights, and so the path from data to decision to sorry from data to insight to decision, if that path is mapped nicely and correctly for the end user or for the decision makers, then you have created a good data model and the data product in your institution and in your and also I want to go at it from I always like to separate two different concepts. One of them is sometimes you have very specific problem, and then you get its data and then you address the problem. And this is usually in conversation somehow mixed up with creating a model for the managing the data at the whole organization with all domains. And that's like really engineering everything or creating this digital twin of your organization. And that's a way more complex problem, and that's exactly what Andrea, I think, was referring to. So these two can be approached in different ways depending on how urgent one is or the other. And I feel the fact that things have changed rapidly in how we store, how we communicate, and where we put our data. Made a lot of organizations like rethink everything, when sometimes what they had was working, or they didn't, or they rethink it fast without really applying their own their actual what works for their own, how their organization operates, how their supply chain operates, etc. So that's my only addition here. From an end user, I want the data product to be available, understandable in its context, and accessible, and in the form that I that's usable. And I've suffered with that with many organizations, like to actually they don't even understand their data. They don't know their columns. Their data is jumbled, and so basically, that's my only take on this.
Yeah, and I think that in order to guarantee what Hala mentioned right now, it's fundamental the modularity approach that has been described by Andrea, right? Because we can see that this type of approach is also seen in other connected scenarios. So, for instance, in the case of software development, there is now this idea of microservices, right? In which you have really specialized service that are able to address a specific purpose. And then when you have to make more complex services, you are able to combine, right, these microservices in a flexible and an efficient way. And it has also an impact in terms of cost, because if something goes wrong on a specific module, right, then you can concentrate your attention to fix only that model while the other continues to work, right? So in terms of a user experience, you can continue to guarantee an high quality service also if something goes wrong or need to be updated in some way.
And if I can just add one thing to close the the round of the table, I think that modularity is also very, very important, not only from an engineering point of view to guarantee the sustainability of the platform, of the solution, but also for the end user agility, business agility, because when you have a reusable module, you can recombine them in a different configuration to create a solution very, very fast. And because the data product have the granularity that guarantee the fact that are understandable from a business user, they also can managing low-code solution or solution that allow to combine product without writing code to create a combination of the already existing product to support new use case in a self-service way. No? So also improve business agility, not only engineering sustainability.
I like that this conversation has centered around the idealistic scenario, and that is taking into consideration the business context and the human context. When complexity gets too great, we need to divide and conquer. When we need to create a new product or a new development, it is use case driven. It is driven by need rather than ego or experimentation. I mean, that has its merits as well, but the primary motive for expending resources should be experiment to solve a problem and make sure that those problems can be expanded. We have two comments here. One is from Jason Kaufman, and I don't know why his profile picture is not showing up, but he says what business processes need to be employed in order to structure data the best. And then we have another comment or question from both John O'Gorman. He's asking, is data centricity on the menu? And I think um, from what I'm saying here is that we're addressing this from a holistic standpoint. These are social technical systems. These are not just data infrastructure. These are systems that are used and evolve with the need of people. So we need to treat them as a holistic term. I came across an article by Ivo Velichkov that he wrote a very seductively in the title, The Case Against Centricity. And that to me was fascinating because he argues the fascination with data centricity here is that people forego the social human component to favor the development of the infrastructure. But it's knowledge driven, it's people driven. So with the context of all this stuff, I want to ask what has been the lessons learned from being in the field, being in the front lines, and gaining a handshake between governance, adoption, and execution of these technologies.
I try to go first on this. Also, let me answer to the question about data centricity because I'm a lot into data centricity. And the more I try to apply the concept of data centricity, the more I understand that the word to describe the concept is probably misleading because with data centricity, what you want to do is not to put the data in a central place, at least, or put the data at the center. You want to put at the center the way you model the data, how you represent the data. Then the data can be centralized in an approach that is usually named dataware. So there is only one service that manages all the data with a specific model, and the application are built around this model, or can be virtualized. The data can be distributed in a different application, but this application relate in some way to the central model. So what is important is to have this federated approach with a central model and data distributed all around, and assess the data through the central model and guarantee the interoperability between the application through the central model. So this is for me data centricity. In terms of governance and implementation, I think that the governance should be as much as possible embedded into the implementation, into the execution. So basically the governance, the central governance, the federated central governance define the policies, define the rules of the game, and then all the decentralized team, when they implement their solution, their data product, have the responsibility to work in a compliant way to the policy centrally defined. This is a must because you want to have a trade-off, and the governor should guarantee this optimal trade-off between the independence of the local team, the agility that the local team can have to solve their own problem, and the fact that the result, the work produced by the local team should also be composable with the work made by other teams. You do not want in a data world to create the only siloed application, that siloed solution that cannot interoperate. So you want to preserve the agility, but you want to put the right level of control in order also to guarantee the composability between the different solutions that are produced by the different local teams. So this is the role of the governance for me. It's a very lightweight governance that just provide the rule that guarantee that the deliverable, the implementation made by the different local team are secure and interoperable.
Yeah, so I think things are changing now in terms of the way we view data governance and data centricity. So the way people are headed with AI and language models, etc., is they're hoping that eventually we'll be able to just chat with our data across the company. Like the person who is not an engineer, not even an analyst, would talk to their machine, like we talk to our assistant or our data head, and tell the machine I want data on this and I want to report on this, and then that machine does everything in between. And that changes the whole model and the whole governance structure, because then who's authorized to ask this question, right? Who's authorized to talk to this machine this way? And the machine should be able to know the authentication and what who's. So it's a very different approach if people want to head in that direction for governance. And the other thing is the rules change all the time. Like so we got, for example, in the US, we got the White House initiative on AI, and then the Governor of Virginia directive, and then you read them, and then you're like, oh, now we have to document this, and now we have to report on this. And the third, so whatever data models you have, whatever implementations you have, they need to adapt to these. It's not like the rules that come are fixed, and they kind of evolve, and the policies evolve. So you have to be adaptable. Your teams have to be adaptable, and sometimes not even realistic. I have one more point. I have one more point to say about this governance. A lot of it is also culture. Some people, they want the benefits, but they don't want to give up their control or their power. So a lot of it is changing how we do things as humans is very hard. And there's an extra point. It will come to me, but I'll let the others speak.
No, I would like just to add really briefly that this handshaking between the data governance and execution is in some way related to the data modeling that we started to discuss at the beginning, right? Because we have to consider an iterative process, as mentioned by Hala. Basically, we cannot define an initial and very well-grounded governance and then at the feet, right, just perform the execution. There is continuous virtuous cycle in which the definition of the initial rules are implemented and tested in the real world. And then if some updates are required from a governance level, then the team that performed the execution has to communicate in a really flexible way with the team of the governance in order to improve and update based on the empirical experience, right? So I think that this virtuous circle between these two different, apparently different steps should be maintained till the end of the development. So I think that this is an aspect that is already mentioned by Andrea and Hala, but I think it was important to underline it again.
I couldn't agree more. And my last point that come to me is about the data approaches and the data-driven, data-centric, data everything approaches. What I want people to be careful about is sometimes it doesn't matter. It doesn't matter if you have all the data in the world on your business question or subject matter, whether it's medical, whether it's business, finance, whatever application you're doing. Sometimes the model you're using will not answer your question. And that's where the actual reasoning process of the model and the machine, like is the data, observing the data is different than changing variables and seeing its effects. Like if I change if I do intervene with the patient, what effect would it show? the observing the data is different than intervening with the data and studying effects, and different than counterfactual with data, like a kind of causal reasoning. So if you want to automate processes, make decisions based on data, you need to be understanding the differences between these different levels, and actually whether you're relying on machine or humans relying on machines, you should be able to communicate like the whole reasoning process, and that's where explainable AI comes into place. And so people can say data driven, data everything when they're in the decision making process, but then all of that has to be transparent, documented, explained, and the models themselves have to be correct. The reasoning followed has to be correct. And a lot of people just ignore that, because in the end, data can tell you anything. Just like probe it from the right direction, you're going to see what you want to see. And that should not be the case. And then that's when we remove the human, and basically we lose our path.
There's another comment from John that he's saying, we should look at data centricity from the language perspective so that it's useful to the language concepts. I would just like to add to that the knowledge centricity. I think that is a more holistic view of that idea, because I think everybody here speaks a second or a third language, and in this area in particular, I live in New Jersey. There's a lot of people that speak Spanish and speak English, or just speak Spanish or just speak English. But that doesn't mean that there should not be a way for someone who speaks only Spanish and English to be able to reconcile the same reality through the knowledge concept, and then branch that off to the language concept. We should be able to be interchangeable just with the conceptual nature of reality. Um, yeah. So with that, any pragmatic advice that we can give to the point of the business process? I know it's not just business process is a continuous; it's an iterative. A lot of people treat these engagements like we're going to do the project and it's going to be the first model and it's going to be a one-off and it should be good enough for now. No, we need to bake it into the model of operations, the culture, as Hala mentioned before the call started. It's redefining how we reason with this framework of thinking. So any pragmatic advice in that realm?
The same that we have suggested for the previous topic. So also at the business level, it is important to approach things in iterative way. No, so try to define, of course, your middle term vision, define clear goal that you want to achieve in order to implement the vision, success metric, and then start to create a portfolio of initiative that you think that can have an impact on the goal that you have defined, and incrementally prioritize this activity to the portfolio and check out if they impact the goal or not, and then invest or reprioritize your portfolio accordingly. So no more big waterfall projects into a strategy that is delivered in a waterfall way for the next 2 years, but just a clear definition of the vision, the goal, the operating model, and then start to iterate and manage your portfolio.
I couldn't agree more, and I think the comment in the comment section is also agreeing, saying exactly what you're saying. I would add the feedback cycle is so important. Do not just go in and just never talk to the stakeholders ever again until you came up with something. Always iterate, feedback, iterate, and you don't always have to apply the latest and hottest technology in your institution unless you see a real need for it. And take that time to think about the trade-offs and the future and the direction of your organization. So do take those moments to talk and think through things with as many people as you can. And also invest time in building your knowledge base. In let's like on if you want your organization to come to the digital age and the automation age, which has a lot of promise, you do. There is no escape from at some point building the knowledge base instead of going to conferences and sitting on panels and talking about it all the time. You do have to sit down and okay, let's do this and let's do the hard work, and it's hard work that pays off a lot in the end. So this is my little advice here.
Yeah, definitely. And I can say that in my direct experience as a consultant in the case of knowledge graph, maintaining this connection with the stakeholders is fundamental, especially then in the cases in which they want to test and approach a new technology like knowledge graph, right? Because this is a really powerful technology, really flexible, and maintaining the connection with the stakeholders and the domain expert allow us to build an application on top of this knowledge graph that could be really, really useful, right? And I think that in this case, this is really fundamental, right? It is also stressed by Andrea and Hala. And yeah, I tested this idea in my direct experience as a consultant, so I can sign their words.
There's a comment that resonates with everything that's being said, probably dividing and conquering the problem into traceable decisions versus summarizing. That's sort of the perspective to take. Thank you, Brandon. Um, dang, I had an idea. I had something to say, and it slipped my mind. But yeah, anything else to add to that while I reclaim that idea that escaped me? Um, yeah. Um, one thing here is that component of iterative nature. There is a knowledge, skills, and experience gap. I mean, this is something that people are not used to. People buy software, they install it, they get someone to service it, or they upskill their engineers or their technical staff to maintain it, and they come with their own models. That is the application centric approach. That is a commercial marketplace as it stands. There are some companies like Salesforce that they say, we'll give you the software. It's flexible, but you have to get somebody that's trained in our software to be able to model it to your needs. I think that's a step up above just having a rigid schema given to you, being able to customize and modify and update. But we're talking about something very fundamentally holistic. And I think, Hala, I think you were touching upon that. All you got to do is talk about what you do already, document it, and then as we reconcile these through more rigid or more formal techniques, we find ways of giving that those ideas shape. Giuseppe, I think you mentioned that you read text, you find concepts, you find entities, you find relationships between these things, and you can start to formalize a model around that. So what would that process look like from end to end, that we can paint a clear picture as to where someone can start today to create a model, agnostic of any implementation, and then decide how to implement that.
I think that, of course, you have to define a couple of things when you are start talking about modeling. So, uh, the type of model that you want to create, the technique that you want to use to create and represent the model, and the operating model that you want to put in place to create and maintain and evolve the model over time. So these are the dimension that you have to clearly define. No? So in terms of technique to represent the model, if we are talking about conceptual models, not physical models, so how the thing that I want to describe is physically structured, but the mental model that I use to represent the thing that I want to model, I think that nowadays a formal representation in the form of ontology is quite popular. So you can check it out more about ontology and ontology engineering as a form of representing the model. But then there is the operating model. So how you create your ontology and how you evolve your ontology over time. And I think that here a federated model is absolutely the key. So every time you have a problem that requires some modeling, you have to bring on the table the domain expert involved in that specific problem, and make them find an agreement on how to represent the object that are involved into the different domain and are correlated to the problem that you want to solve. Find an agreement on how to represent them. So from a technical point of view, create the representation is a technicality. It's quite simple. Okay, you need a technical person that write the RDF, the oval, whatever. The complex thing is to find an agreement or understand on what the different person in the business disagree upon. No, this is the different thing. So for me, the different thing, the complex thing is not to create an RDF ontology, a file, but to find an agreement on what is a customer between the VP of sales and the VP of marketing. Having their time, so they're in the same room and they have to agree. Okay, the customer for us is this thing. It's not easy. It's not easy.
I would agree 100%. I would start actually there in what the goal is and who sits at the table to actually address this goal. So what teams, what VPs, what individuals down the institution sits at the table. Once you have, if you have these agreements, then you start building and implementing. The other thing is I do want people to realize the power of the new technologies and all the data that can be integrated into the same problems they were solving before. Suppose they're solving a poverty problem or a flooding problem, or like things that I'm actually going to sit on a geospatial panel in this afternoon. But say, so the amount of to build things that are flexible to ingest different types of data, like images from like drones and I don't know, fractures or in manufacturing or in the supply chain, logs, like kind of the powerful thing. I would say if there's only one powerful thing about the AI hype, it would be this one thing only, is the ability to integrate data from many sources and many forms of data and combine it and make sense of it into the same decisions to answer the same questions that people used to answer in the past with very rigid schemas and very tabular. And so to me, like, to people kind of have the flexibility to build models that are able to integrate these kinds of things. It's expensive computationally, and but it's to think in that direction as well. That's the only thing I add.
Yeah, and taking the words from Andrea and Hala, I can see that they focus on the different perspectives that we can have on the artificial intelligence, right? Because Andrea mentioned this idea of formal representation in which we can use ontologies in order to define specific rules and create this model to describe the information, right? And to perform also advanced reasoning, which is always under control. It's predictable, so it can use for very specific and very precise purposes. And Nala mentioned this other perspective of AI that is actually embrace the LLMs, right? In which the rule emerge from the bottom, right? So basically extracting patterns from the content, you can create a new knowledge based on what the model was able to capture from the world. And the capacity of combining these two technology and overcoming the cultural issues related to what Andrea mentioned before. So basically I can see only my needs and my department. I have a vision only on my specific square, I would say. Then these two things, I think, that should represent the development in the next future, right? So basically evolving in terms of the cultural approach to the data and the capacity of combining technologies that try to address the same problems with a complete opposite perspective. I think that it should be really interesting to investigate.
If you guys are with us still up until this point, I hope you weren't lured in with the provocative nature of data centricity and AI. I think we talked about and dispelled some of the misconceptions around what it is. I think we came out a whole lot richer, and you got the perspective of these three experts in the field doing consulting work, working with private, government, nonprofit. I mean, these people have really been in the trenches and they know what they're talking about. And I think ultimately, what we want to say here is you can take a complementary approach to using these technologies like generative AI and LLMs, but you have to go in knowing that everything that you create has to start with humans, has to be touched by humans, has to be curated by humans, and needs to be tested continuously through the eyes of humans to make sure that it fits in the right context. Because context and people are what define the utility of a system, not the technology itself. And yeah, thank you guys for showing up, and it was a good panel discussion.
Thank you, Joaquin. Take
Thank you
care
again.
of.
It was a pleasure.
Thank you.
It's for
Always
me.
fun talking. This is warm.